Hello everyone, my name is Jen. My roll number is 19EC01025. Today I am going to explain my mini project about a solar power system to charge the laptop for 3 hours of SS lab. So these are my laptop specifications. My laptop is a Dell Inspiron 3576 series of 15.6-inch FHD laptop, and the processor is 8 Gen and i5 core, and 8 GB RAM and 2 TB HDD storage, 2 GB graphics card. And most important specification which is required to build a solar power panel system is battery specifications. The laptop battery is of a 4-cell smart lithium ion, and the full charge capacity is 37.326 milliwatt hour, and the battery life is up to 5 hours. And here I am considering 4.5 hours as my laptop battery life. If we move on the equipment required, the first most important equipment for this project is a solar panel, which generates the electricity using the solar energy, and the next one is the inverter. Here the electricity is generated by the solar cells is DC, and since our household appliances or a laptop adapter needs a AC, inverter is used to convert DC to AC. And the next one is the battery. In order to store the electricity generated so that it can be used as a backup power when the panels are unable to generate the electricity. And the last one is solar charge controller. It is an electric device that adjusts the direct current voltage output either up or down from the input level, and it controls the electricity between the module battery and the loads, such that it preventing the damage of the battery by ensuring that the battery is operating within its limit, and also ensures that if the charge level in battery is a low level, and will cut the current to the loads, preventing the further discharge. So these are the descriptions on the equipments. If we move on to the next slide, this is the block diagram, and this slide is all about the basic connections between the equipments from the solar panel to the load. Firstly, I'll connect this solar panel module of 10 watts to the charge controller, which is which is a capacity of 10 amperes and 12 volts, and then it is connected to the inverter or converter. Here I am assuming the efficiency of 80% and converter capacity of 200 watts. Finally, I am connecting this converter to the load or laptop, and for power backup I am using the battery, and it is connected to the charge controller. And now in this slide I am going to do some calculations for the equipment requirements. For inverter, I am using the calculations that input power for the load equal to 37.362 watt hours divided by 4.5 hours, that is equal to 8.30 watts, and the energy required by the load for 3 hours assuming per day, it is equal to 8.3 into 3, which is equal to 25 watt hours, and the input power for the inverter assuming minimum 80% efficiency, that equals to 8.30 divided by 0.8, that is equal to 10.375 watts, which is less than the capacity of the inverter, that is 200 watts. So one inverter which is of 200 watts capacity is required. Then to find out the number of charge controllers requirement, I am using the batteries of 12 volts, and I got the input power for the inverter is 10.375 watts before, and we know that I equal to P by V, that is equal to I equals to 10.375 divided by 12, which is equal to 0.865, and which is less than the 10 amperes. So one charge controller which is of 12 volts and 10 amperes capacity is required. For a solar panel, for calculating the number of solar panels, I am using the minimum solar radiation in my area, that is equals to 4.59 kilowatt hour divided by meter square per day, and that is 4.59 hours of sunlight per day, and the energy due to the radiation for 10 volts 10 watts solar panel equals to 4.59 into 10, that is equals to 0.0459 kilowatt hour per day, and we know that number of solar panels is input energy required by the interval for 3 hours divided by the energy due to the radiation for one solar panel. So solar panels equals to 10.375 into 3 divided by 0.0459 in kilowatt hours, which is equal to 0.681. That is, one solar panel is of 200 watts is required. Sorry, 10 watts is required. Now if I want a power backup for 2 days, total amp hours equals to 31.25 watt hours into 2 divided by 12 equals to 5.521 amp hours. So the number of batteries equals to total amp hours divided by the battery specification, which is of 5.21 divided by 7, that is equals to 0.744. That is, only one battery is required, which is of 7 ampere per hour. And this is the budget section. After finding the requirements, I would like to buy the 200 watts converter, which is of 599 rupees, and the next one is a solar charge controller of 10 amperes, and the cost is 699, and the next one is a 985 rupees for the 12 volts and 7 ampere hour battery. And the most important equipment is of a solar panel of 10 watts module, which is of module dimension is 305 into 355 into 22 millimeters, which is the cost is 889. And including the miscellaneous items like wires, creams, charge, cigarette lighter, etc. My total budget is 3100 to 3500. That's it. Thank you.